You know that pencil sitting on your desk? What if I told you that the secret to the next generation of computers is hiding inside of it? It sounds like science fiction, doesn't it? But the answer might just be yes. Today, we're going to peel back the layers on an incredible material that promises to change, well, pretty much everything. All right, let's get into it. We are talking about graphene, a material so packed with potential, it's often called the material of tomorrow.
And its story, you'll be surprised to hear, begins somewhere incredibly simple.
That's right. If you take the graphite from a pencil, the lead, and could somehow impossibly peel off a layer just one single atom thick, you'd be holding graphene. It is literally the thinnest, strongest material humanity has ever discovered. And its secret? It all comes down to this structure. Look at that perfect honeycomb pattern. Each carbon atom is bonded to 3 others, creating this ridiculously stable and strong hexagonal grid. This perfect arrangement is the foundation for all of its mind-bending properties. And you know, people had theorized about it for decades. But it wasn't until 2004 that scientists at the University of Manchester actually managed to isolate it. And the story goes, they did it with nothing more than graphite and some sticky tape. Seriously, that one simple act kicked off a global scientific gold rush. So what's all the excitement about? I mean, it's strong, sure. But that's not the whole story. Let's talk about its most incredible property, how it handles electricity. Think about a normal conductor, like the copper in your wires. For an electron, traveling through that is like driving down a bumpy country road. You get there, but there's a lot of resistance slowing you down. Graphene, on the other hand, it's a perfectly smooth, multi-lane superhighway with no speed limit. Electrons just fly through it with almost zero resistance. So the big question is, why? Well, this is where things get a little weird. Inside graphene, electrons start behaving as if they have zero mass. Physicists have a name for this. They call them Dirac fermions. This massless property is what lets them zip along at nearly the speed of light. It's what makes graphene such a phenomenal conductor. And this is the reason why. What you're looking at here is a map of the energy levels in graphene, known as a Dirac cone. The real magic happens right there, at the very tip, where the 2 cones meet. At that one single point, this unique energy structure allows electrons to behave as if they have no mass at all. This right here, this is graphene's superpower. But you know how the story goes. Every superhero has a weakness, a kryptonite, and graphene's? It's a really, really big one. For all of its jaw-dropping potential, especially in electronics, it has this one fundamental problem that has held it back for over a decade. Okay, so to get this, we need to talk about something called a band gap. Now, putting it simply, a band gap is basically the off switch for electricity in a material. It's what allows you to stop the flow of electrons when you want to. This is exactly why silicon is the king of computing. It has a perfect band gap. That's what lets our transistors create the zeros and ones, the off and on states that are the foundation of all digital information. Graphene, with its amazing electron superhighway, has no band gap. The switch is permanently, hopelessly stuck in the on position. And that right there is the billion-dollar question. How can you possibly build a computer chip with all its complex logic using a switch that you can never, ever turn off? The simple answer is, you can't. But what if you could give graphene the one thing it's missing? What if you could actually engineer an off switch from scratch? This is where the really clever science comes into play. So how in the world did they do it? They figured out a way to literally force a band gap into existence. Okay, let's walk through it. We start with the normal Dirac cone, right? See how the tips are touching? That's the always-on problem. So first, they apply a very specific electric field, which starts to warp the system. Then, and this is the killer move, they add a magnetic field. The combination of these 2 forces breaks the perfect symmetry of the graphene and physically pries the tips of those cones apart. That new space they've just created between them, that is the band gap. That is the off switch. So the key insight is this. By carefully applying these electric and magnetic fields, they can actually break the fundamental rules of physics that kept graphene's switch stuck on. They are, in essence, hacking the material itself, forcing an energy gap to open up and giving it the control it was never born with. So, with this incredibly ingenious hack now on the table, what does this actually mean for the future?
Well, it means the dream of graphene-based tech is suddenly back on. We're talking about electronics that are orders of magnitude faster than anything we have today. Supercapacitors that could charge your devices in seconds, all new kinds of advanced biomaterials, and even a new path to exploring next-generation superconductivity. It's a huge deal.
And this isn't just some fantasy. The potential here is so massive that the European Union has invested over €1 billion into a single project, the Graphene flagship. That's a pretty clear sign that this is no longer just a lab curiosity. It's being treated as a cornerstone of our future technology. So let's just quickly recap the whole story here. Graphene is this one-atom-thick sheet of carbon with superhero-like electronic properties, all thanks to its massless electrons. But its fatal flaw was a lack of an off switch, which made it useless for computer chips. But now, scientists are figuring out how to engineer that missing off switch using clever electric and magnetic fields. And that leaves us with one final, really exciting question. With its biggest hurdle now on its way to being solved, what part of our world do you think this one atom-thick material from a pencil will revolutionize first?